Dear children, I welcome you all to the Science Corner of AJ Studio. The objective of this video is to determine whether chemical reactions has taken place or not. To learn this, we are going to do two different activities. Children, are you all ready to do an activity? Yes, the first activity is we are going to check what happens when lead nitrate solution reacts with potassium iodide solution. Before doing an activity, let's see the aim and what are the things are needed to do an experiment, and then we will start an experiment. Okay, children, the aim of this experiment is to determine the reactions taken place when lead nitrate solution reacts with potassium iodide solution. For doing this activity, we need a lead nitrate solution, potassium iodide solution, and we need test tubes, and we need a spatula for mixing it, and we need a distilled water for dissolving it, and we need a test tubes holder for keeping the test tubes. Now let's start performing an experiment. Take 3 test tubes and fill one test tube with distilled water, and take another test tube and fill it with lead nitrate salt with the help of spatula. And take another test tube and fill it with potassium iodide salt with the help of spatula. And now take a distilled water, add to the potassium iodide salt, dissolve it and make a potassium iodide solution. And then add a distilled water to the lead nitrate salt and dissolve it and make a lead nitrate solution. Once the lead nitrate solution and potassium iodide solution is ready, we have to mix the lead nitrate solution to the potassium iodide solution and see what happens. Dear children, when lead nitrate solution mixes with potassium iodide solution, a yellow precipitate forms. That is because of the formation of lead iodide. Such type of chemical reaction we call as precipitation reaction. Dear children, here not only the precipitation reaction has taken place, even the double displacement reaction also has occurred. Let's learn about the precipitation and double displacement reaction in the next video. Now let's discuss about the chemical equation for the formation of lead iodide. And dear children, we all know that the symbol for lead is Pb, and for nitrate it is NO3, and for potassium it is K, and for iodide it is I. So for lead nitrate we have to write as PbNO3, and for potassium iodide we have to write as Ki. So when lead nitrate, that is PbNO3, mixes with Ki, we get Pbi, that is lead iodide, and we get KNO3, that is potassium nitrate. Dear children, now have you all understood how should we write the chemical equation? Now let's move to the next activity, that is what happens when zinc granules reacts with either dilute HCl or sulfuric acid, that is H2SO4. Before we perform an experiment, let's see the aim and what are the things required to perform an experiment. Okay, the aim of this experiment is to find out the reactions taken place when zinc reacts with dilute hydrochloric acid or dilute sulfuric acid. And for doing this experiment, we need zinc granules, dilute hydrochloric acid, sulfuric acid, 2 beakers and matchbox. Now let's start performing an experiment. For doing an experiment, we had taken zinc granules, hydrochloric acid, sulfuric acid and a matchbox. Now take a zinc granules and put it in the first beaker that contains HCl and in the second beaker that has H2SO4 and see the reaction happens. We could see a small bubbles that are coming up Why could we see the bubbles coming up? Dear children, it's because of the formation of hydrogen gas. How shall we know that hydrogen gas has formed? To find out that, let's keep the flame near to the mouth of both the beakers and see what happens. Dear children, did you all hear some sound? Good. That sound we call as popping sound. This we could hear it's because of the formation of hydrogen. Dear children, do you all want to hear that sound again? Yes, come, let's hear it. Yes, did you all enjoy hearing the popping sound? Good. Children, whenever dilute hydrochloric acid is added to zinc granules, zinc metal displaces hydrogen and zinc chloride has been formed. Because zinc is more reactive than hydrogen, so it displaces the hydrogen and forms zinc chloride, and finally the hydrogen gas is evolved, and because of this we could hear a popping sound. And this is the same thing happens in case of dilute sulfuric acid. Yes children, whenever dilute sulfuric acid is added to zinc granules, we all know that the zinc is more reactive when compared to hydrogen, so it displaces hydrogen and forms zinc sulfate, and finally the hydrogen gas has been evolved. Now let's learn about the chemical equations of both the reactions. Children, see here in the first one, we all know that the symbol for zinc is Zn, and for hydrochloric acid we have to write as HCl. Okay, when zinc reacts with HCl, see here we know the zinc is very reactive, so the zinc displaces the hydrogen and we get zinc chloride and hydrogen gas has been evolved, and this is the thing we have discussed before. And now let's move to the second reaction, that is when zinc reacts with sulfuric acid. The formula of sulfuric acid is H2SO4. So when zinc reacts with H2SO4, the zinc, as zinc is very reactive, it displaces hydrogen, and because of this we get zinc sulfate, that is Zn-SO4, and hydrogen gas, that is H2, has been evolved. And because of this hydrogen gas we could hear a popping sound, and here the zinc displaces hydrogen, and because of that we call this reaction as displacement reaction. Now let's come to an end. Children, can you all tell me what could you all infer from activity 1.1, that is about the burning of magnesium ribbon? You might have learned this in video number 1, and activity 1.2, that is adding of lead nitrate with potassium iodide, and activity 1.3 is about adding zinc with HCl and H2SO4. Yes, we can infer from the magnesium activity that when magnesium ribbon has been burnt and mixed with water, it has changes its state from solid to liquid, and from this we can say that the state of magnesium ribbon has been changed. And from the second activity we could infer that the color of the substance has been changed. Yes, when lead nitrate is reacted with potassium iodide, it produces lead iodide and potassium nitrate. Here the color of lead iodide is yellow. So from this we can say that the color of the substance has changed from colorless to yellow. And from the third activity we could infer that the temperature of the substance has been taken place due to the evolution of a hydrogen gas. From these observations, that is change in state, color, evolution of a gas and change in temperature, we can easily determine whether a chemical reaction has taken place or not. And I'm hoping that this video might be helpful to all the children to know about various changes happens during chemical reactions. And thanks for watching my channel, and keep supporting, keep watching, and don't forget to subscribe.